So speaking of also the format that the data is stored in the archive files, if you recall at the beginning of the presentation, we showed we mentioned that we would also talk about the part of Chapter 10 that specifies how the data is encoded into the archive files at the recorders. So it's pretty simple. Basically, this packet structure that goes inside the UDP payloads as you're streaming the data across the network, that essentially defines the structure of how the data, the avionics bus data, is encoded into the archive files at the recording system. So, and then same thing for the files as you would have with the streams. You can have a Chapter 10 archive file can contain data from one or more data buses, and even one or more avionics data buses of different types. So you can have a mix of 1553, 429, whatever type of avionics data stored in the same Chapter 10 archive. Also, at the beginning of the Chapter 10 archive file, at the beginning of every one of those, there is a setup record that basically provides the definition of the configuration of the recording device. So this would indicate all of the avionics bus interfaces, for example, that were available and configured and present on the recording device that recorded the data, and it would give you the channel ID and the bus type for each of those avionics interfaces in the recorder. So this is nice because, say you have hours and hours of recording in an archive file, you don't want to have to, I guess, go pick through that whole file. Maybe spend several minutes up to even hours spinning through that file to try to just determine which buses and which data from which channel IDs are in the file. You should be able to just look at a setup record within the first few kilobytes of the file to find out which channel IDs and which bus types were even present at the recorder when the data was captured that's contained in the file. Chapter 10 also specifies even the file system that's used on the mass media where the archive data is stored. So the idea was to be kind of operating system, file system independent, even down to the level of the file system. So just kind of for your information, Chapter 10 also describes how the file system should be implemented and put together in the mass storage directories and subdirectories for the archive data. So what we're going to jump into here next in a few moments is a demonstration of some of the software tools that we have here at AIT that we can use to kind of show you how to capture some data coming from a Chapter 10 stream, and also how to open up and look at some of the archive file formats. So just kind of I guess a pictorial of my setup here. So what I have basically running on another PC in the office here. I have something that's essentially emulating an output stream from an avionics recorder. So it's sending out a Chapter 10 stream from a separate PC on the LAN in the office here. And then I'll be sitting at my laptop basically that I'm doing the presentation from, and I will use our MIL-STD-1553 data bus analyzer called Flight Simulator. I will be using that to capture that stream of 1553 data from the Chapter 10 stream, and then display the data, the message data, in the 1553 analyzer. Then what we'll also take a look at too is within the Flight Simulator analyzer, we will open up a Chapter 10 archive file that came from a flight data recorder. We'll actually open up the same file that's being used as input to the utility that's simulating the stream of the archive. And so we'll be able to open that up and look at it, and also show you that we can take data that we capture from the Chapter 10 stream, and we can save it out to a proprietary, I guess kind of a more efficient way that we save the data so that we can process it and open it and look at it. So we can take the data from the Chapter 10 stream, save it out to our proprietary format, or also to a Chapter 10 archive file format, and then also be able to open directly from the archives. So if you give me a few moments here, I will get the demonstration set up, get our software application started up, and get the Chapter 10 stream kind of live and going out here on our network. So stand by for one moment and I'll get going here. Okay, here we go now. So I'm going to start with the demonstration. I have a couple of different PCs on the LAN here in the office that are running, that are basically sending out IRIG Chapter 10 streams. So I'm sending, basically emulating on the network the situation where you would say have two recorders, two recording devices, each with their own IP address, each their own node on the local area network, and each one sending out a stream, a Chapter 10 stream over Ethernet, and then each stream contains data, multiplex data from two different MIL-STD 1553 data buses. So I'm going to start out not in our software tool, but just within Wireshark here, a network packet capture utility. Maybe a lot of you are familiar with. And so if I just start a live capture here, you can see that I have a lot of data going on the network. I know for each of the devices, that the two simulated recorders out there, that I'm sending them on two different UDP port addresses. One is sending the stream on port 2000, so I'm going to apply that and restart the capture. And you can see here I have a lot of traffic coming at the PC here on UDP port 2000 from the IP address of 192.168.1.54. So I see that's one host that's sending what I know is a Chapter 10 stream on port 2000. I also have one, we run it and we can see it's still live, a different host at 192.168.1.63 sending broadcasting actually Chapter 10 stream to port 2001. Okay, so now I'm going to flip over here to our flight simulator tool. So we've seen that we've got the data going, a couple of Chapter 10 streams on a couple different UDP ports on the network. So first thing I'm going to do is tell the flight simulator tool that I can expect a stream on port 2000, which is one of them that we saw it on in the packet capture. And I can see I've got a couple different channels multiplexed onto the port 2000 stream. So now I'm going to flip over to our simulation and I'm going to capture the data off of one of those streams into the bus monitor. And you can see that I've captured several packets here from channel ID 7. I could also go through and capture from channel ID 8. And we get all of the data that we expect to be able to look at, just like we do with capturing off a normal bus. So we can see the timestamps, the type of transfer, primary, secondary bus that it, whichever of the bus. So yeah, so we can see whatever of the, which bus side that it came from. We can see the command word. If there's two command words like an RT to RT. Basically, basic 1553 analysis. We can also see all of the raw data, so we can break it out instead of by message. We can see each bus word, including the timestamps that were captured off the bus. And we can additionally, for each bus, if we don't want to look at all the message data, if we just want to see what's active out there on the bus, we can use our RT monitor activity displays. And so from the Ethernet stream, we're showing here just a summary of the live remote terminals that are seen in that data capture stream. So we can also, that was kind of just a quick demonstration of the streaming, what we can do as far as capturing and showing the streaming data. We can also, if we've already captured data from a Chapter 10 stream, we can go ahead and open that up to view it in the flight simulator tool. So here you can see I have a file that the header at the beginning of the archive file that we talked about previously shows that there were 6 different 1553 data bus interfaces on 6 different channel IDs configured for that that recorder at the time that archive file was recorded. So I can select one of them, say channel ID 7, and I can see there was no data on that channel ID. So I can try that file again, and I can see, if you remember from our recording, this is the recording file that we were using to play the streams. We know that there was data for channel 7 and channel ID 8, so I'll pick 8, and we get all of the captured data that we can go through and analyze and take a look at from the Chapter 10 file. So just a little visual there of basically what you see in the file, and then we can also go ahead and we can save that data back out to just a binary format that the flight simulator tool expects. We can also save it out to comma separated file if you want to post-process it using Excel or something like that. Just a text file, or we can save it back out to a Chapter 10 archive And if we're going to save it out to a Chapter 10 archive, we want to know. But if we're just recording with the flight simulizer tool here, we don't necessarily have that channel ID, or we may want to save the captured data out to a different channel ID. So we can specify it here, select it, and save the data out. So that concludes our presentation today. I will flip back over and show you our contact information again, in case you want to get in touch with us. We appreciate you taking the time to check out what we've got and to listen to our little overview today. Again, if you have any questions about MIL Standard 1553 or specifically 1553 over Ethernet, or any of our software products that we've demonstrated here very quickly today, please feel free to contact Ken or I, or as I said at the beginning, we'll wait online for a little bit. If any of you want to use the chat utility here, we'd be happy to kind of interact with you in real time after we're done here. So thanks again, appreciate your time. Have a good day. Bye-bye.